All right. Folks, if there's any other quizzes out there, keep chipping away. Is there any out there? Go ahead. No? We're all good? Okay. Awesome. All right, let me turn this thing on here. All right. Is it too loud back there? All right. Folks, I hope that you've had a chance to try some of these first, what we call this review here, this review of expanding. Here, let me get a little bit bigger here. Okay. Remember this, expand? You remember this back in grade 9? This is the lesson last year where we had those little baggies and they had the magnifying glass and you look at what's inside of them, right? Remember that? The distributive property? Or maybe that rings a bell? Or maybe you're like, yeah, I have no idea what you're talking about. So, folks, the distributive property is essentially right here. Like, this is what it is. And I know you're really good at it because in our first unit, linear systems, when we were subbing in a binomial into a variable, we had to use the distributive property to kind of get rid of those brackets. Very similar to something like this, right? We have 4 times x plus 3. And this box up here is telling us that we're going to do a times b plus a times c. And a lot of us, we're like in grade 9, we're like, please draw in those arrows. They are so important. In fact, they're so important that we'll probably give you some sort of mark if you weren't even able to answer the question at all. We give you something if you put in the arrows. So when we expand something like this, there's a step that you got so good at and you didn't even show it. But for this example, I am going to show it. So what's going on here is we have to multiply 4 times x and then 4 times 3. So we start off with an equal sign and say 4 times x plus 4 times 3. And a lot of us did not, well, maybe at the beginning we did this step, but when we got so good, we didn't really need it because we went right to here, 4x plus 12, right? Does that sound familiar? Can I get some nods or some shakes? Yeah, lots of nods. Good. Now, if you look out front of this bracket in part B, it's a variable. And that can be a little tricky, and this is kind of combining some of the things we learned in grade 9. So x times 5x and x times negative 7. So what I like to do is this. X times 5x, and I'm going to say plus x times negative 7. Now, a lot of people might say, oh, whoa, Mr. Yakimish, should be minus x times 7. Who's thinking minus x times 7? Is anyone in? Who's thinking that's fine? What I wrote there is what you'd probably write. Yeah, depending on how you look at this thing, yeah. The reason why I like to put a plus x is because I see the x out front here is positive. So I'm going to keep it as positive. And the sign to the left of the term, I say belongs to the term. So this would be I know it's x minus 7, but it's really also negative 7. So now when we multiply this, well, x times 5x, does anyone remember the result of something like that? Yeah, Camille? Yeah, 5x squared. 5x squared plus, and then x times negative 7 would just be negative 7x. And you could go one more step, and you should go one more step, but for the sake of space, you should say 5x squared minus 7x. Yeah. Okay, this last one here, we kind of ramp it up a little bit each time. So this one had a number out front, this one had a variable out front, and this one is a whole term out front. So, I did not do that. Okay. So we're going to go 5x times 3x, and then 5x times 5. So 5x times 3x plus 5x times 5. And when we do this was actually a pretty big mind-blowing move in grade 9. And a lot of us, even for me, I remember teaching this stuff. It's like, oh, yeah, look at the numbers as numbers. 5 times 3 is 15, and then x times x, we add the exponents. Do you remember that? That was to get x squared. And that was a pretty big moment in grade 9 math. And then we got here 5 times 5 is 25, and then the x just comes along for the ride here. Now, this is what we call, and in the new grade 9, we call this multiplying a monomial, which is a one-term polynomial, by a binomial, which would be a two-termed polynomial. And when you multiply a monomial by a binomial, you're going to use the distributive property. And I think we're really good at that. But moving on to grade 10, we're going to multiply, notice here, two binomials by one another. And it's not so bad. In fact, a lot of what we do here comes from the distributive property we know and love and we're familiar with. And I'm going to show you how. A lot of this stuff, you're not going to have to write anything down here. It's all here. It looks a little intimidating, but I promise you it's not that bad at all. With the distributive property, when we multiplied a monomial by a binomial, we took the numbers out front and we multiplied it by whatever was in the second bracket, right? So that's exactly what's going on here. We're taking the A and multiplying it by the whole thing here, and then we're taking the B and multiplying it by the whole thing here. Do you see that? You see that? A times the blue bracket, B times the blue, and that's like the distributive property, 2 times. Now that it's set up like this, we're like, okay, here we go. Bing, bang, boom, and Bob's your uncle, right? And that's the distributive property twice. Not so bad. And after that, we notice that we end up with, of course, A times C, right? And then A times D plus B times C plus B times D. And we end up with this, something like that. Now, if this is all true, and it is, then what we can say is that this bottom line here is equal to this top line here. And that's what I've stated right here. They're quite literally equal to one another because they're the exact same thing. So, if you notice, have a look here. A times C, there's kind of a shortcut here, and we call the shortcut FOIL. A times C. And then the next one is A times D. Check that out. So we start at the A and we distribute. And then what's next? B times C. Okay, no problem. B times C. And then the last one here, B times D. Okay? So a lot of us, especially grade 10 AP, we're going to look at this, multiplying binomials, and it's basically doing the distributive property 2 times. Once starting at the A, distribute, distribute. Another time starting at the B, distribute, distribute. Any questions about that? Some of you might not like that at all. And if that is you, we have this acronym. And this acronym is called FOIL. The reason why we call it FOIL is because it's essentially just a method of multiplying these things. Multiply the first terms, then the outer terms, then the inner terms, and then the last terms. So that might sound a little weird, but for some of us, it might be the thing that we're missing all along. Hello?
Sarah is on in class?
Yeah.
Can you come see the process, please?
Sure.
Yep.
FOIL. The first terms, when we multiply the first terms, what they're talking about here is that, like if we're looking at just this example down here, the first terms in the bracket, the A and the C. Yeah, first. Next would be the outer, which means the A and the D. The outside ones, this one and this one. Then the inner terms, the B and the C. And then lastly, the last terms, the B and the D. A lot of the time I refer to multiplying binomials, I'm going to say, oh, FOIL, FOIL. We call this FOIL, but really it's double distributive property, but we just call it FOIL. Questions before I move on? Right? Maybe we should do some examples here. Okay. Here's an example of what the FOIL is actually saying here. Let's say we have x plus 2 times x plus 5. If we follow the acronym FOIL, this is what they're saying. Okay, first multiply the first terms, x times x. Next is, oh, the outside terms, which means the x and the 5. See the outside there? Next would be the inner or inside terms, the 2 and the x, and then the last terms, the 2 and the 5. Not sure if follow. Who says FOIL is what I'm going to follow, and that's what I'm going to do? Yeah, we got a couple. Who's saying, oh, no, double distributive property. We just start at this one and then that one. Okay. Now, for these first couple examples, I am going to just follow along with FOIL. I like FOIL. Then maybe I'll show you it in double distributive property. So in this particular polynomial, we have 2x minus 1 and x plus 4. So when I look at the terms here, I'm thinking, okay, 2x, I'm thinking negative 1, I'm thinking 1x, and I'm thinking 4. So FOIL will be first terms. Here we go. 2x times x. That's the first terms here. And 2x times x is 2x squared. Next would be the outside terms. Outers. 2x times 4. 2x times 4, I believe, is positive 8x. Next, the inside terms. Negative 1 times x. Well, negative 1 times x is negative 1x. And then the last terms, negative 1 times positive 4 would be negative 4. Whoops, that's in green. Negative 4. Yeah? Okay, now, can we collect any like terms here? You see any like terms? Yeah, usually there's always going to be like terms in the middle here. There'll always be them right there. So, we got 2x squared, and we got 8x minus 1x, and that's positive 7x minus 4. And that's it. Now, if you look closely at this thing right here and this thing right here, what quadratic form do these look like they're in? Yeah, they look like they're in factored form. And when we use FOIL and then expand and simplify these things, what form do they turn into? Standard. So really what we've learned here is to go from a factored form, we use FOIL, and we get to a standard form. So maybe we could even just note that. Factored form, we use FOIL, and that puts us in standard form. It's kind of nice. Okay, folks, expand and simplify. These are great questions. I think I'm going to show every ounce, every step of my work that I'm doing here. So my first thing that I like to do, me personally, is I like to start at the x, multiply like that, and multiply like that. So my first thing here, I'm going to say, all right, here's my equal sign, of course. I'm thinking x times x plus x times 7, right? And then I go on to the second term in here, the 3, and I'm going to go 3 times x and 3 times 7. So plus 3 times x plus 3 times 7. Now, do we need this step? Absolutely not. Just like in the distributive property, we didn't need that first step. But it's pretty good, I think, especially when we're learning this stuff, to see what's going on. So now we can go ahead and simplify all of these products. X times x is x squared. X times 7 is 7x. 3 times x is 3x. And 3 times 7 is 21. Usually, you'll probably start at this first and then end up right here, just like the distributive property. And then, when we collect like terms, usually the answer is always yes. And we'll get x squared plus 10x plus 21, because 7x plus 3x is 21. Sorry, is 10. Ooh. Question? So far, so good? Great. Okay. This is a special one. It's a special one. It's got a very special name. When we move into Unit 4, we're going to love these. Notice that they both have an X and they both have a 5. The only thing that's different is that one has a plus and the other one has a minus. Watch how this works out, because for all kinds of pairs of binomials that are multiplying by one another that have this sort of pattern in them, they always end up the same sort of way. So x times x is x. And we got x times negative 5 is negative 5x. 5 times x is positive 5x. 5 times negative 5 is negative 25. Now, have a look at what happens here. We have to collect our like terms, and our like terms are negative 5x and positive 5x. So really, how many x's do we end up with here? 0. So we have x squared plus, 0x minus 25. But to write 0x is a little redundant. We don't usually write that because 0 times anything is 0. So we get x squared minus 25. Cool? Questions so far? All right. You're probably wondering, does this get a little bit harder? It does, just a little bit. And I'm going to show you. Maybe we got to do a couple more examples. Oh, we're doing tons of examples. Okay, how about this? Oh yeah, this is the one where it gets a little bit challenging. How about this? You try these on your own. Try the next 4, right? C, D, E, and F, just these 4. And then the last 2 we'll do together. So I'm going to be coming around. If you have questions, let me know. But yeah.
That's one. Another option.
Don't forget your equal signs going down the left-hand side. I love that I'm seeing people use calculators here because it's like you go so far. You don't want to fumble the ball. No chance. Use a calculator, absolutely. All right, I'm going to take up the first one, I think, here. X times x is x squared. X times negative 4 is negative 4x. Negative 3 times x is negative 3x. Negative 3 times negative 4 is positive. Wow. Sneaky. Sneaky. See that one? They kind of threw us for a little loop there. And then the double negative here. Negative 7x plus 12. Now, a couple things to notice. One, did you draw the arrows? Because I like to see the arrows. Some people don't like to draw them, but I love the arrows. The next thing here, be careful with your signs, right? Negative 4x, negative 3x, and a positive 12. That could be a little, slippery slope. And then make sure here that you got negative 7x in the center there. A lot of my grade 9s would say negative 1x because they're still working on collecting like terms with integers. Also, note the equal signs going down the left-hand side. That's for math form. We're kind of simplifying an expression here, so we should have those equal signs going down the left. All right. We got 2x squared minus 14x minus 3x, and then again, look at this, plus 21. That's the only thing about this is that when there's minuses in the brackets, we got to be extra careful. We get 2x squared minus 17x plus 21. Folks, any questions so far? Are you checking them as you go? They look good? Okay. Ooh, all pluses. We're happy about that. 2x times 3x is 6, and then x squared. 2x times 2 would be 4. Oh. It's happening more and more. I'm scared this thing's going to give up on me soon. 2x times 2 is 4x, yes. 1 times 3 is 3x. 1 times 2 is just 2. Collect our like terms. The like terms, you notice how they always come up. They always come up here in the center. Now, that's no coincidence. In fact, these like terms in the center are very special numbers, and they make everything work out nicely. When I say that to you, that kind of doesn't really mean a whole lot until we go into our next unit. Our next unit is going to be, we're going to be hunting for these numbers. That's really what we're doing in the next unit. Okay, and this last one here can be a little misleading because here's what I see. I'm going to show you the biggest mistake in grade 10 math. You ready? So this is wrong. I'm going to let you know that this is wrong. So maybe I should even write this. This is wrong. But here's the biggest mistake in grade 10 math. Biggest mistake in grade 10 math, right? Do you see what happened here? A lot of us got addicted to these exponent laws, and we're like, oh yeah, the exponent 2 is going to go everywhere in there. Right? So just be cautious. Whenever something is squared, what we're really saying is it's something multiplied by itself. So 2x minus 7 squared, in brackets, all squared, really means 2x minus 7 times 2x minus 7. That's what we're talking about. That's what we want here. And from here we go. 4x squared minus 14x minus 14x plus 49. And then we go 4x squared minus 28x plus 49. Does that look good? Look okay? It looks a little different than what we have in blue over here, doesn't it? So just be cautious of that. I see this error quite a bit, so I really want to make it obvious here as to what's going on. Questions? Okay. Maybe a question's coming up about these two. Now, if you notice, it's factored form with the a value up front. And here we go. There's actually two ways to do each of these. So maybe for the first one, I'll do one method. And then for the second one, I'll do another method. Okay? Sound good? Each method is going to work no matter what here, but it's just whatever you're most comfortable with. So the first thing you could do, maybe we could call this method number 1. Here we are. The first thing you could do is, I'm going to rewrite this here, just because I can't reach up there. The first thing we can do is take this, because look, it's 3 times x plus 5 times x plus 6, right? The 3 is timesing by all of them. It's very similar to, remember you're in a bedmath situation? 6 times 2 times 3. Yeah, remember this? And you do one operation at a time. The first thing you do is 6 times 2, which is 12, times 3. And then 12 times 3 is 36, right? Do you remember that? When life was so nice, right? Grade 8 maybe? Yeah, grade 9. So what's happening here is notice how we multiplied the first thing by the second thing. Yeah? That was the first move. Well, that's going to be our first move here. 3 times x, 3 times 5. We're just going to take that leading value, the 3 out front, and we're just going to multiply it by the first thing, the first term here, the x plus 5. And that makes sense, because that's like just doing the 6 times the 2, right? So it will end up with something like 3x plus 15, and then x plus 6. And from here, I know you can take it away. And we're just going to FOIL this. Expand it, simplify it. Here we go. Here, perhaps I can move this a little bit out of the way. Okay. So 3x times x is 3x squared. 3x times 6 is 6, 12, 18. 18x. 15 times x is 15x. 15 times 6, 90. And then we get 3x squared plus 33x plus 9. Not so bad. Method 1. We like it. You could almost leave you to it, and that's it. That's all you'd ever have to know. If you're not a fan of that, right, trash can this? Oh, look at that. If you're not a fan of that method, I'll show you method 2. Method number 2. Okay, I'm going to rewrite this here. Negative 2, x plus 1, x minus 9. Method 2 says ignore that number out front. Ignore it. Pretend it's not there, okay? So we're just going to FOIL. So x times x is x squared. X times negative 9 is negative 9x. Plus 1x. I always put a 1 there. You don't have to, but I do. Minus 9. We've just FOILed, and we're going to collect our like terms, right? Like we always do. X squared. Oh, don't mess me up here. Minus 8x. Okay, minus 9. Right? And it's like, if we were just doing FOIL with no number out front, that's what we would end up with. But because we do have a number out front, we just do a triple distribution. Negative 2 times this, negative 2 times that, and negative 2 times that. A triple distribution. So we go negative 2x squared. Now, negative 2 times negative 8 is positive 16x, and negative 2 times negative 9 is positive 18. You will get the same answer for each of those using whatever method, one or two. You could almost just pick one and roll with it, and that's all you'd ever need. You only need one of these two methods. Folks, any questions? Which is pure multiplying binomials. That's all we got. All good? I'm going to maybe show you one more thing, just for fun. I love to show this to grade 10s. Let's just say we have, I don't know, someone give me a binomials. What do we got? Help me out. Let's make one up. 2x minus 7, and we'll do x plus 5. Heard a 5 out there? Sure? Now, what we can do here, I don't know why that bracket looks so large here, is some people like to call this the window method, which works just great. Remember when we were teaching you multiplication and they used that rectangle area thing? Same idea can work here. See this 2x and the minus 7? Let's say, okay, 2x and minus 7. That's this one here. And we'll take the other one, the x plus 5, and we'll call this the x and the positive 5, like that. Now, all we do is we kind of just multiply, right? We're going to multiply x times 2x, and we get 2x squared, right? And in this kind of quadrant, we'd be doing 5 times 2x, which is 10x, right? And then down here, we'd be doing x times negative 7. And then the last one would be negative 7 times positive 5, which I believe is negative 35. Is that what it is? Okay, now from here, we're just going to line up the terms from the highest degree to the lowest degree. So essentially, write it like a quadratic, you know? So it would be like 2x squared plus 10x minus 7x minus 35. We collect our like terms here in the center, as always. 2x squared plus 3x minus 35. And that's another way, if you want, if you like that, that's great. Well, for most students, that'd be like my grade 10 applied students, they would be all over this and using this like every single time. But usually in the AP, they just go, oh, no, distributed property, I got it. But this is a beautiful method. It works just as great. Cool? Cool. Okay. Folks, there's some homework here. Now, I kind of need you to do enough of this multiplying binomials until you say, yeah, I'm sick of it. I need you to get to that point because this is great. This is great. This is something that won't go away, really. So yeah, 4 to 7, 8, and then 10, A and C on page 166. Seems like a fair amount. I think after that amount, it's like, yeah, you should be a pro. Just make sure you're going to the back and you're checking your answers because there's no sense of doing all this stuff and not really checking. Okay? Is it really?
That's just like